Hello, VJ and Mick here. Today we're going to show you how to save time and money on your plant design project through the use of a simple pipe stress analysis application. CheckStress performs quick stress checks of piping lines from 3D design program drawings. Although this particular version of CheckStress can import most PCF output file formats from a wide array of design software, today we will be using AutoCAD Plant 3D from Autodesk. Let's start by exporting a line out of AutoCAD as a PCF file. The first thing we're going to do is identify a suitable line that we wish to test for possible stress issues in our drawing. I have chosen line 10001 in AutoCAD Plant 3D's sample model that comes available with their evaluation version. Once you identify the line, the process is very simple for extraction. From the ISOs tab, click on the PCF Export button. This will bring up the Export PCF dialog window that lets you select your piping lines and designates a save location for the exported files. So we just navigate to 10001, click on it. You can set your export save location here and then click Create. Now let's see if this piping line has any potential stress issues that we need to know about before we finalize our AutoCAD drawings and submit them to the stress engineers. It's actually quite easy to do. Here's how.
Thank you, Mick. This is VJ here. I will show you the check stress part. You just saw Mick extract a line from AutoCAD Plant 3D as a PCF file, and he saved it. So I'm going to read that file and show you what CheckStress 2 can do for you. The primary benefit, as Mick might have mentioned before, is as a designer, you can quickly qualify which lines need further stress analysis, which lines don't. The two basic things you're going to use for qualification of lines will be basic code compliance for the thermal case and the sustain case. These are two primary cases that any piping code first asks you to validate. And CheckStress does just that. You don't have to do anything except get the line from AutoCAD Plant 3D and run it through CheckStress. It takes about 30 seconds. Let's do that. So first I'm going to browse over to the file that Mick saved, load it, click here. It automatically fills in the output file name for you. Select the vertical direction if you need it and click on Apply. CheckStress grabs the file, analyzes it, and then presents you stress contours, stress ratios, and deflected shapes. Now, let me minimize that here. Now you can see that CheckStress presents to you the stress ratios for three cases: expansion stress, sustained stress, and the occasional stress for seismic evaluation. It also shows you deflected shapes for those same cases and some other advanced features here. And finally, you can save this as a kpipe or a CAESA2 file for further stress analysis by your stress engineer. A cool blue, as a stress contour shows here, means that there are no issues with the stress for the thermal case. In this case, you do see blue all over, so there are no problems anywhere here. Now, anything red indicates that the stress ratio is at 1 or higher than 1. So let's click on sustained stress, and you will see that this line has possibly one or two issues because it's red in this area here. You can immediately tell as a designer that there are no supports and hence the red, the overstress. How can you make sure of that? Click on the sustained deflected shape and you can see that there are no supports and hence there's a huge sag which results in a higher sustained stress. Now at this point you can simply decide to send this file over to the stress engineer as a kpipe file or a CAESA2 file here and let the engineer deal with further stress analysis. Or you could make the edits yourself in AutoCAD or right here in CheckStress by clicking on Edit Layout and you can see whether your fixes, because you have access to the general arrangement drawings, you know where the steel is. So you can put a few supports here on this line, on this horizontal run here, and then see if it helps you. But if you want to do simply a check of the stresses, then this is all it is. Expansion stress, flexibility wise, it's clear. This line, sustained stress has a problem, so package this off to a stress engineer and you're done. Now go on to the next line. So that's it. Any advanced features here will be discussed in another video, and just look for another video to follow. Thank you.